arc length. So let us review basic concept from algebraic functions. So recall that for an algebraic function y equals f of x, where x is between a and b, meaning is a is lesser or equals x lesser or equals b, then the arc length is L equals integral a to b. Under the radical sign we have dx squared plus dy squared and integration with respect to x. So where dy dx is f prime x. All right. Now we will consider a vector function rt equals xt comma yt comma zt, and t is between a and b. Then arc length will follow the same definition. So first we need to find the derivative of it and then put it in the function where you see the integral from a to b, and under the radical sign you are just taking those components is squared and integration with respect to t. Now we'll take two examples. We have our vector function rt is 4t negative sine t negative cosine t, and t is between negative 3 and 1. So find r prime t. So 4t gives me 4 when I take the derivative with respect to t. The derivative of sine is cosine, so you get negative cosine t, and cosine t derivative is negative sine t, so that's why that negative sign goes away and you get your derivative. Next we use the formula here. So in this case I should have here plus sign, but it doesn't affect my answer anyway. So 4 squared gives me 16, and cosine squared t plus sine squared t will give me 1. And then integration of dt, my function is, you can just say 1, so that will give me t. Now when you take the limit negative 3 to 1, so first you plug 1 minus negative 3, that gives you 4. So we are done for the first example. Now we'll take second example. In this case our function is 9 radical to t, then 3 e to the 3t minus 3 e to the negative 3t, and my t is between 0 to 1. So we'll take the derivative again, and you can easily see the derivative look like this. The reason is very simple. You know the chain rule of derivative. So if you have forgotten how to take derivative of e to the 3t, you can see on the side. So I'm taking derivative of e to the 3t is e to the 3t, and the derivative of top gives me another 3. So that's why 3 e to the 3t multiplied by this 3, that makes it 9. Same way we get this one. Now we'll use the formula for the arc length. So what happens now, you can see we'll take integral 0 to 1, that's my t here. So the components I have 9 square root of 2, that will be squared, 9 e to the 3t will be squared, 9 e to the negative 3 also will be squared. So then now you can see here 9, here 9, all these three places I have 9 is a common term with a square. If I take that one outside the radical sign, it will be just 9. So remaining will be square root of 2 squared, that gives me 2. And then the rest same way goes e to the 3t squared and e to the negative 3 squared dt. Now it is very important, you can just look at here, when I have e to the 3t and I have squared in here plus e to the negative 3t I have squared in here plus 2 times e to the 3t times e to the negative 3t, you can see that this one is coming out as e to the 3t plus e to the negative 3t squared. Because this term here, you see that e to the 3t times e to the negative 3t, just e to the 0, so it is just 2, that you can see exactly here. So that one is basically e to the 3t plus e to the negative 3t squared under the radical sign, so that's why that removes. And then after that we just integrate between 0 to 1, and as you know, e to the 3t, when you integrate, it gives you like this, integration of e to the 3t dt is e to the 3t over 3. So we have a 9 here, so that 3 will cancel this 9, you put a 3 in here. So using that integral, as I said, this 3 will cancel this 9 to 3 here, and that 3 again comes from the second term. So basically, after putting the limit from 0 to 1, I will end up with this result, and we are done.